In this lesson, we are going to have an introductory look into operators. Now, what is an operator? Well, essentially, these are symbols that tell the computer to perform certain mathematical operations. If, for example, we wanted to increase the value of a number or increase the value of a variable, we would use operators to do so. Now, there are many different types of operators. In this lesson, we are going to be focusing on four main ones: addition, subtraction, multiplication, and division. Okay, if you ever wanted to manipulate numbers in any certain way, pretty much you can do everything with just these four. Now, let's look at a little example, okay? So, for example, if we wanted to increase our variable by a certain amount, we would first of all declare the variable, and then to increase it, we would go num plus equals 2, okay? So plus equals basically means we are adding whatever is on the right to whatever is on the left. Now, let's jump into Godot and have a look at how we can set this up. So what I'm going to do is start off by creating a new variable here. I'm going to call this one score. It is going to be of type integer, so a whole number, and we'll make it equal to 0 to start off with. Now, let's go down to the ready function and print out score. Now, if we were to play our game, we would see score, the number 0, being printed in the output here. But before we do that, let's go ahead and modify score a little bit. So we already know that we can change the value of a variable by writing it down, then going equals, and then we can give it another value. So for example, here, we are changing the value of score to be 10. But what if I don't want to make it equal to 10, but I want to perhaps maybe increase it by 1? Well, to do this, I can simply go score, then plus equals 1. Now, what I am doing here is I am essentially increasing score by 1. The plus equals basically means that the number on the right is going to be added to the number on the left. So what do you think is going to be displayed in the output when I press play? Well, if we press play, we can see that the number 11 has been printed, okay? Because we are setting our score to be equal to 10, then we are increasing it by 1. Likewise, we can also subtract. Now, subtraction is basically going to work in the same way. We're going to go score minus equals, and then we can enter in, for example, let's just say 5. So if I press play, we're going to have a number, if you can guess correctly, of 6. Okay, so we are subtracting 5 from the score. Now, for multiplication, it's going to be a bit different, okay? You might be thinking, okay, we go, for example, score, then perhaps x equals 2 to multiply by 2. But no, we do not use x for multiplication. Rather, in programming, multiplication is denoted by the asterisk symbol, okay? If that'll be the alternate key on the 8 number, okay? So asterisk equals, and then if you want to multiply that by 2, we'll then go asterisk equals 2. So now, remember, up to this point, the number is 6. So hopefully, when we press play, the number will be 12. And there we go. And then, of course, to divide, again, this is a bit of a different symbol because, you know, when writing down mathematics, we have the division symbol, but we don't really even have that on our keyboard. So to divide, we're going to go score / equals, and then if we want to divide, let's just say we want to divide it by 4, okay? So then we can go /equals 4 to divide by 4. And if I press play, we can see that we have the number 3, okay? Because 4 times 3 is 12, and 12 divided by 4 is 3. Okay, so those are all the operators that we are using here to increase a number by an amount, to subtract a number by an amount, to multiply by an amount, and to divide it by an amount. Now, we can also do the same thing with floating point numbers. So if I create a variable here, and let's just call this one perhaps speed, okay? And this is going to be of type float, and we'll make this equal to 5.5. Now, let's just say we are playing our game and we want our player's speed to all of a sudden double, okay? Well, what we can do is we can go speed and then multiply equals 2. Okay, and if we print out our speed, well, that of course is going to be 5.5 times 2, so that's going to be 11. And there we go. But since we are working with decimals, we can also then multiply it by decimals. So if I go speed times equals, let's say we want to make a very intricate amount. Let's just say we want to go 2.548. Okay, so we are multiplying it by a very intricate amount, and of course that result is going to appear right here. Likewise, we can also then divide by these intricate amounts, okay? We can go speed, divide equals, and then we can divide that by perhaps 2.09, okay? And that's going to result in a very obscure number, okay? So you can see how we can use the addition, subtraction, multiplication, and division with not just integers, but floats as well. Now, you may be thinking about another thing, and that is, what about strings, okay? So, for example, a string is essentially text, and you may be thinking, hey, can't we just add text together? And you would be correct. So here, what I'm going to do is I'm going to create a variable, and I'm just going to call this one, I would call it text of type string, and we'll have this text just say first, okay? Now, if we go down here, what I'm going to do is I'm going to go text, which is that string variable, plus equals, and then we can simply give another string. So we can go then second. Okay, just like that, and then print out the text. Now, what do you think this is going to look like? Well, if I press play, we are essentially going to stick those two strings together. Okay, you can see first, second. So what we're essentially doing here is we are getting this text, this string, and we are simply slapping this other string onto it. Now, when it comes to using operators with Boolean variables, that's not really a thing because a Boolean can either be on or off, true or false. So we can't really increase true by a number. We can't really multiply but false by anything. So that is kind of its own thing. But integers, floats, and strings we can add. And then with floating integers, we can use addition, subtraction, multiplication, and division. And hopefully now you can start to piece together sort of how you would utilize these things. For example, if in your game you have a health potion, the player would pick up, and then we would go, for example, health plus equals 5 or something like that, and that is a way of increasing the player's health then. So you'll be using these operators all throughout your programming journey. Alright, so let's have a bit of a challenge. What I want you to do is I want you to create a money variable with a value of 10. Then I want you to do these 4 steps with each of them utilizing a unique operator. I want you to first of all add 5 to the money. I then want you to double it. I then want you to take 3 away from it, and then I want you to half it. So have a go at that, and I'll be right back to see how you. Alright, so I hope you had a go at that challenge. Now let's hop over into Godot and have a look at how we can complete it. Okay, so let's start by creating a new variable here called money. I'm then going to make this a variable of type int, so it's going to be a whole number, and we'll make it equal to 10 by default. Then down inside of the ready function, what we're going to do is first of all add 5. So I'm going to go money plus equals, for addition, 5. then we need to double it. Now, an easy way of doubling 15 is by just multiplying by 2. So we can then go money asterisk equals 2 to multiply by 2. We then want to take 3, so we're going to use subtraction. So money minus equals 3. And then finally, we want to half it. And to half it, we are going to divide money by 2. So money / equals for division 2. And then finally, we can print this out to see what the final result is. And you can make sure that you have the right number being printed out. So we'll save that, press play, and you should have 13 being printed out to the output. Okay, so we've looked at these operators, but there is also another way that we can utilize operators, okay? So what I'm going to do is I'm going to go down to a new line inside of the ready function, and I'm going to create a new variable called a, and I'm going to make this of type int, and this is going to equal to 5. Now, you may be thinking, wait a minute, you're creating a variable inside of a function, and yes, you can actually do that. Variables can be created pretty much anywhere, but that limits what's known as their scope. Since I've created this money variable outside of the function, if I were to create more functions inside of this script, those functions would be able to utilize the money variable. But since this a variable has been created inside of the function, that means only the ready function can utilize this variable, okay? You can sort of think of it as its sort of vision, how far away it can see or be heard. If you're inside of a function, you're inside of a hole, so nobody outside really knows that you exist. Whereas if you are outside of the hole, everyone can see you and hear you, okay? That's just a bit of a weird way of thinking about it, but that is essentially the basics of scope in programming. So with this a variable, what we can then do is, for example, go a, and then we could do something like a equals 10 plus 2. Okay, we can use addition, multiplication, subtraction, and division, not just to modify the variable directly, but instead to modify other things. So what I'm doing here is I'm setting a to be equal to the sum of this equation. So a is now equal to 12. Likewise, I can also go a equal 5 and then maybe times by 10. Okay, so then a is going to be equal to 50. And we can also keep stacking these up. So I could go 5 times 10 plus 2 plus 81 and then divided by 6, you know, and that is going to work. Okay, that is going to basically calculate this equation right here and then equal the result to the a variable. Okay, so you can do all of this complex mathematics without really needing to know the answer yourself, as that is the point of having the computer do it for us. Now, we can also do this with variables, okay? So for example, if I create another variable here called b, and this is of type int, I can make b equal to, for example, a times 2. So now the variable b is going to be equal to whatever a is at this point in the code multiplied by 2. Okay, which is pretty cool. And then down here, for example, I could create another variable called c of type int, make that equal to 0, and then go c equals a divided by b, okay? And you can see how you can begin utilizing all of these variables in your equations as well, okay? Variables are not just static and have to take in raw numbers, as generally you will be multiplying things by variables. For example, if you want to move your player around, you would not just increase their position by 10 or increase it by 5. You would increase it instead by a move speed variable, which then defines how far the player moves, okay? So you'll be using variables in all these different ways all throughout your journey in all sorts of different scripts. And throughout this course, we will explore the different ways that we can utilize variables. So thank you for watching. And in the next lesson, we are going to be exploring the concept of conditions, okay? Being able to branch out our code. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson we are going to be exploring conditions inside of coding with Godot. So what is a condition? Well, conditions essentially allow us to check to see if a certain statement is true or false. Now, we can use, for example, the equality operator, equals equals, to see if two values are equal to one another. So if we go 5 equals equals 5, that statement is true. If we then go 3 equals equals 7, that statement is false because 3, of course, is not equal to 7. So what do we do with these things? Well, we then plug this into what's known as an if statement. If statements allow us to check to see if a condition is true. If the condition is true, then we run the encapsulated code. Otherwise, we skip over it. You can think of an if statement basically as a way of branching our code, okay? Because at the moment, we're sort of just running every single line of code that we come across, whereas if statements finally allow us to not run code or do run code if certain things are true, okay? In this example here, we have a variable called a, which is equal to 5, and then we have an if statement that checks to see if a is equal to 5, and if so, we are printing condition is true. Now, if I change a to be equal to 6, that code, print condition is true, will not run. Okay, that line of code is only going to run if a is equal to 5. So now let's look at setting up some conditions inside of Godot. So I'm going to start by creating a new variable here. I'm going to call this variable score, and I'm going to make it an integer variable equal to, let's just say, 10. Now what we can do is go down into the ready function here, and we are going to create our first if statement, okay? I'm sort of interchanging between if statements and conditions. Basically, think of it as an if state checks a condition, okay? So here I'll go if, and then I'm going to write down the condition. The condition here is going to be score equals 10. And then we add a colon to basically denote this is the end of our statement. We then press enter to go to a new line, and you should see that is then indented, okay, 1 tab's width to the right. And here we can enter the code that we want to run when this condition is true. So here I'm just going to go print, and I'm going to print out score is 10. And there we go. So again, we have our if statement right here, which contains a condition, and this condition is checking to see if our score variable is equal to 10. Now, we are not going to go if score equals 10, okay, because in programming, equals and the double equals serve different purposes. A single equals sign is used for assignment, okay? This is what we would use to assign the value of 10 to score, whereas a double equal sign is used for comparison. And then down here, indented into the if statement, is the code that we are going to run when the condition is true. So if I press play, what you'll notice, of course, is down here we have score is 10 printed to the output. But if I go ahead and change our score variable to maybe, let's just say 5, and run this, what do you think is going to be printed to the output here? Well, if you guessed nothing, then you would be correct, because this code is not being run because the above condition is not true. So an if statement only runs its code if the given condition is true. Now, we don't just have equals equals to check to see if one value is equal to another. We have a wide range of different ones. So let's check to see perhaps if score is greater than a certain number. So here we could then go if score, and then I'm going to do the greater than sign. So basically the right pointer like this. It should be shift full stop on your keyboard. Let's go greater than 5. Then what we're going to do is print out score is greater than 5. Okay, just like that. Essentially, what we are doing here is we are checking to see if the value on the left is greater than the value on the right. So if I press play, what should you see? Well, you're going to see nothing. The reason why is because score, first of all, is not equal to 10, and score is not greater than 5. It is 5. So if I change my score now to be 6 in the variable up here and press play, you should see that we do get score is greater than 5. Now, we don't just have to work with variable and number. For example, I'm going to create 2 variables here, one called a, which is going to be equal to 50, and one called b, which is going to be equal to 100. Now, down here, what I'm going to do is I'm just going to check to see if a is less than b, then print, and we'll just print out a is less than b, okay? Now, a is 50 and b is 100. So 50 is less than 100, so this print line is going to run. So if I play, there you go, we can see it is being run. Okay, and one final thing we're going to look at in this lesson is going to be the opposite of the comparison operator, and that is going to be not equals. So, for example, let's go down here. I'm going to write if a exclamation mark equals b, what do you think this condition is checking? Essentially, this condition is checking to see if A is not equal to B. So here I'll print out A is not B. And if I press play, we should see, since A is 50 and B is 100, A is not B gets printed out. But if I go ahead and change A to be 100, now A and B are equal. So what do you think is going to be printed out? Is this line going to be printed? Well, let's press play, and what you'll see is it is not, because the condition we are checking here is A is not equal to B. So if A is not equal to B, this code will run. If A is equal to B, this condition is false. So we'll simply skip over the code here. So lastly, let's go over what a condition and what an if statement is. A condition is essentially just a thing we are checking to see is true or false. Okay, is score equal to 10? Is score greater than 5? Is A less than B? Is A not equal to B? These are conditions that return either a true or a false value. Now, an if statement is essentially just checking to see if a condition is true, and if so, we run the encapsulated code. Okay, so if statements and conditions work together. Now, in the next lesson, we are going to explore more about conditions and start to actually expand on different ways that we can utilize it. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to continue looking at conditions and if statements, and in this lesson we are going to explore the idea of not just if statements but else if and else. So what am I talking about? Well, let's get started. So let's just say we have a score variable here and we want to grade our user. Okay, we want to give them an A, B, C, or D grade based on their score, and let's just say this is a number that ranges from 0 to 100. Okay, if they have a score above 80, they get an A. If it's above 30, they get a C, and anything else is a D grade. Well, let's go to my ready function, and here I'm simply going to go if score is greater than 80, then we are going to print out A. Okay, seems simple enough. So if I press play, since 100 is greater than 80, this is going to print. But what if we then want to give them a B? Okay, like I said, if their score is, for example, above 60, that is going to be a B. So then I could go to a new line here, go if score is greater than 60, well then we can print out B. Okay, seems simple enough. Let's press play, and what you'll see is it says A and B. We don't want that. We want only one or the other. So what we can do is use what's known as an else if statement. Now I'm going to write this out first, and then I'm going to go over how it works. So here we are writing if score is greater than 80, and then we have our code that is running. I'm going to go to a new line, go backspace to go in line with our first if statement, and then I'm going to write elif, which stands for else if. And then I'm going to write my second condition, which is score greater than 60, okay? Exactly what I've done before. Then I'm going to print out B. Now, if I save this and press play, what you'll notice is that we only have A written out. Or if I change my score to, let's just say 70 and play that, you'll notice that it says B. So before it was printing out both values, but now it is only printing out one. Why is that? Well, it's the way that the else if statement works, okay? Basically what our computer is doing is it is going line by line inside of the ready function. So we start with this condition, okay? If score is greater than 80, then print this. If that is not true, so if this condition does not get run, then it looks for an else if statement, okay? Down here we have elif, score is greater than 60, if so, print B. Basically, if the above condition is not true, we then check this condition, okay? And if that one's true, we then print. But if the above condition is true and it runs its code, we do not check any following else if statements, okay? You can sort of think of it as, you know, if score is greater than 80, do this. Otherwise, if score is greater than 80, do this. We are essentially adding in an additional check if the first condition is false, okay? And we can actually stack these up. So we could then go elif score is greater than 30, then print C. So you can basically stack these else if statements atop one another and keep on going. Now, along with else if, we have one more, and that is the else statement. Okay, so we'll go else, colon, go to a new line, and then print out D. Now, else basically means that if all of the above if and else if statements have not succeeded, then whatever is in the else code here, we are going to run. Okay, so if score is not greater than 80, if it's not greater than 60, if it's not greater than 30, then we will run the code inside of else. In that case, printing out B. So if I give myself a score of, let's just say 20, we should have D printed to the output, which we do. Okay, so that is a look at the if the else if, and the else statements. And also, just in case you're wondering, yes, you can put if statements inside of if statements. So if you wanted to then do something like this, so we'll go if score is greater than 80, print A, and then we'll go if score equals 100, we can then print out, for example, perfect score, okay? So if I set my score here to 100 and then play that, it'll basically say A and perfect score, because if the first condition here is true, it runs all the code inside of it. And since the code here is an if statement, we then check that and then run the code if that is so, okay? So you can stack if statements inside of one another like that. All right, so now I want you to have a bit of a challenge. I want you to first of all create a Boolean variable called game over. Then, if the game is over, print go to the menu to the output. Otherwise, print keep playing. So have a go at that, and I'll be right back to see how you've done. All right, so I hope you had a go at the challenge. Let's now hop over into Godot and have a look at how we can complete it. So to start off with, we are going to create a new variable called game over of type boolean. Now, we don't write out the full boolean word, we just write down bool, and this is going to be equal to, let's just say true by default, okay? Then down inside of the ready function, we are going to basically write an if statement that's going to check the condition game over equals true, okay? Now, if game over is equal to true, then what we're going to do is we are going to print go to menu, otherwise, so we can write else, we are going to print keep playing, okay? So now if I go ahead and press play, since game over is true, we should have go to menu printed to the output. Whereas if I change the value to be false, we should see keep playing printed to the output, which is what happens, okay? And again, you can use all sorts of different variables with conditions, okay? Here we are using a Boolean variable. The same thing could be used for a string. So if I create a string variable here, for example, called password, okay? And let's just say the password is 123. We can then perhaps have a condition that checks to see if password equals 123, and then we could have a print that says enter, okay? So if I press play, you'll see that since the password equals 123, we have enter printed there, but if I write down another number for the password here that is not 123, that enter print line is not going to run. So we can use both boolean, strings, int, we can use anything that we want when checking our conditions. Now, of course, you can't check to see if game over is greater than true, okay? The greater than, less than, those are really mainly used for numbers that have sort of a spectrum-based value, but things that have sort of a rigid value like text or true or false, those are great for using the equals, or not equals conditional operators. Hey everyone, in this lesson we are going to be exploring functions inside of GDScript. Now, functions are essentially reusable blocks of code that we can tell the computer to run. So we might have a function for making the player jump. We might have a function for adding score. We might have a function for updating our UI elements, okay? And in Godot, the engine has many built-in functions, and we are going to be looking at two of them, as well as creating our own. Now, you may already be familiar with the ready function, which we have been using in the course so far. And essentially, the ready function gets called once at the start of the game when whatever node the script is attached to gets initialized. But then we also have the process function. Now, the process function, this gets called every single frame. So if you're having code that you want to, for example, move a player around on screen, you would use the process function to do that. So now let's hop into the engine and have a look at setting this up. Okay, so here in Godot, we've already got our ready function that we have created before. And what I'm going to do is basically print out ready inside of the ready function. And if I press play, well, of course, you'll see ready gets printed out once in the output. Now let's also go ahead and create the process function. So I'm going to go over exactly how the function declaration works in a second, but basically we go func func underscore process. And you can see when I'm typing out my function, you can see that this list pops up of all the different functions that we can use that Godot provides us. So we're going to use the process function here that in brackets says the word delta. I'm then going to print out process. Now, if I press play, what you'll notice is that the output gets filled up with these process lines. And if we look over to the right, we can see that there are over now 300, 400 messages being printed to the output. Okay, every single frame we are printing process to the output. Okay, so that's pretty cool. I'm just going to replace this with pass for now. Same thing inside of ready. Now, what a function essentially is made up of is a number of things. Okay, we first of all have the word func, which is basically how we declare that this line is the start of a function. We then have our function name in blue. Then we have an opening and closing parentheses. Now, this is basically where we put in what are known as our parameters. Now, a parameter is essentially information that can be sent over when a function is called, okay? And then we have a colon to denote the end of the function declaration. Then any code that below that is indented once is going to be a part of that function. Again, pass is essentially just a placeholder code, just so we don't have any errors for having an empty function. Now, process down here, you'll notice, has a parameter, okay? It has a parameter called delta. And this is basically a number that gets sent over every single frame with process. And delta is essentially just the time between frames, something that you can use if you want. And this is actually of type float. Okay, so now let's look at actually creating our own custom function. So what I'm going to do is I'm going to go down to a new line here, and I'm going to write a function called welcome message. So I'll go func and then underscore welcome underscore message. Okay, remember, we pretty much want to use snake case with our naming conventions. So basically using lowercase letters and underscores where we would put a space. Now, why am I putting an underscore at the beginning of the function? Well, general practice in Godot is to basically have all private functions with an underscore and all public functions without an underscore. What is a private function? What is a public function? Essentially, private functions are functions that will only be called within the script, whereas public functions are functions that will be called from outside the script, okay? So essentially, welcome message is only ever going to be used and called within this script here. So we have an underscore. I'm then going to have an opening and closing parentheses, a colon, and then on a new line, I'm going to print out welcome to the game. Then what we can do is basically run our game. But what you'll notice is nothing is going to happen. And the reason why is because even though we have declared our function, we are not actually calling it, okay? And for a function to run, we need to call it. So how can we run a function? Well, I'm going to go to the ready up here, and I'm going to write down the function name, so welcome message here, and then add an opening and closing parentheses. You'll see that this line of code is now blue, and basically this is how we can call a function. So now if I press play, you'll see that the welcome message function is going to be called once at the start of the game. Now I could also go ahead and call this function down in the process function here. And so the welcome message is going to be called every single frame, okay? Now, let's have a look at creating something a bit more complex. Okay, we are going to be looking at creating a function that can, for example, add two numbers together. So what I'm going to do is I'm just going to remove the call here, just write down pass. And I'm going to write a new function, okay? This function is going to be called add, and it is going to actually have two parameters. So to add in a parameter, we simply just give it a name. It can be called whatever you want. I'm going to call this one A, and then to add a second parameter, I'm going to go comma B. Now we can add as many parameters as we want. We could add maybe this, we could then maybe add a time parameter, we could add a delta parameter, all sorts of things we can add. So we have A and B. Now I'm going to add a colon. go to a new line, and inside this function, we are essentially going to add these two values together and print out the result, okay? Something pretty simple. So I'm going to create a variable called sum, and this is going to be equal to a plus b, and then we want to print out the result. So we are then going to print sum. Now, if you have noticed, the print line of code is actually a function itself, okay? We have the function name, an opening and closing bracket with the parameter in the middle, okay? Print is essentially a function we are calling, which then logs a message to the output. Okay, so we've gone ahead and defined our add function. Now we need to call it. So up inside of ready, I'm going to write down underscore add, and then I'm going to have my opening and closing parentheses. But as you can see, this is resulting in an error. The line of code is red, and down here in the output, we have an error message. The reason why is because we are trying to call a function that has two parameters, a and b, but we are not sending anything over. So whenever we declare a function with parameters, we need to add them within the parentheses. So here I'm going to add together, for example, maybe 5 and 8. So now that we have our two parameters sent over, if I press play, we should see the 13 gets printed to the output. Okay, that is the sum of these two numbers. Now, in the next lesson, we are going to continue on with functions, looking at returning values. So thanks for watching, and I'll see you all then. All right, let's continue looking at functions. So we've already looked at how we can create our own custom function called add, which takes in two parameters, a and b. Now, a good way of thinking of parameters is basically like temporary variables, okay? We are essentially declaring a variable for this function to use, okay? And once this function has finished running, those variables essentially just get deleted. Now, inside of the ready function, we are calling the add function, adding together 5 and 8. And what this is doing is then printing out the results. But what if, for example, we wanted to have that result? What if we wanted to be able to then use it? Well, that is where returning comes into play. Returning essentially is the final little topping of a function, okay? A good way of thinking of functions is like a factory. You have inputs, you then have the process, and then you have the output, okay? For example, inside of the add factory here, we have A and B as the inputs being shipped in. Then we have the calculation here being actually, utilizing those parameters and creating something new. And then what we can do is return, which is then outputting the result. So what I'm going to do is replace the print line of code here instead with the word return, a space, and then sum. So what we are doing here is returning the sum, but what does that mean? Well, what we can then do up inside of the ready function is print out this function here. Now, this looks a bit strange. I'm printing out a function, but since we are returning a value here, basically you can look at this as being the number that gets returned. So if I press play, we should have the number 13 in the output, okay? A better way of looking at this might be like this, all right? So I'm going to create a variable here called results, and this is going to be equal to the add function, which is going to send over the number, let's just say 33 and 91. Then what we can do is print out that result. So we can go like so. Now, basically what we are doing here is the add function is going to add 33 and 91 together. It is then going to return that number. So returning it basically means that it is then going to, in its essence, be equal to that number. And we are then assigning it to the result variable and then printing it out. So if I press play, we should see that 124 gets printed. So that is basically the basics of returning values. Again, you can think of a function like a factory. You have inputs such as the parameters here. You then have the process, which is essentially the code that we run inside of the function. And then finally, we have the output, which is us returning whatever, I guess you could say, we created within that function. Now, not all functions have returning values, and not all functions have parameters. You can see the ready function here has no inputs or no parameters, and it doesn't have anything it returns. It's essentially just us saying we want to run this function, and we then do. Whereas with process, it has a delta parameter, but no output. And the add function that we created has both inputs and outputs. So basically, you're free to create your functions however you wish. Now, let's go over one more thing, and that is statically typing our functions. Because when we're declaring a variable, up here, for example, we'll create a variable called score. We'll go int equals 5, for example. Now, this int here is basically us statically typing our variable, aka defining the type hard-coded, okay? Again, this is not something you have to do, okay? Writing down score equals 5 works just fine, but if you have a bunch of variables, it's generally nice to know exactly what that variable type is. So statically typing it by declaring its data type is a good practice to follow. Now down here with our add function, we have A and B. Now, what is A and B? If you're basically sending this code over to a team member to work on, they might look at A and B and go, is that a number? Is that a boolean? Is that a string? You know, it's kind of hard to see this way. So what we can do is statically type our parameters by basically having the parameter name, then add a colon, and then its type. So we'll go float, because we might want to be able to add together decimal numbers. And then B, that might also then be a float. Okay, so essentially what we are doing here is we are defining the type of value that must be sent over as A and as B. And then also some here we can define as a float as well. And then the second thing is going to be defining the return type, okay? Because even though this function takes in floats, we might want to return a string that says, you know, we had success, or we might want to return a boolean, true or false. So also defining the return type can be valuable. Now to do that, I'm going to go to the end of the function declaration here, just before the colon. I'm going to go space. I'm then going to add in a dash and then a greater than sign, okay? So it looks like a little arrow, and then I'm going to write down float. So essentially what I'm doing here is I am saying that the add function is going to return a floating point number, a decimal number, with this little arrow pointer here. Now again, this is optional, but it is best practice to follow, as later on, if you go back to an old function and you see all these different parameters with weird names, in your head you might be going, hey, I don't know if that's a number, I don't know if that's a boolean, I don't know what information is being sent over. Whereas if we add in its data type, it can become a bit more obvious. All right, now let's have a little bit of a challenge. I want you to go ahead and create a function called has1. Now this function is going to have a parameter called score, which is going to be of type int, and it then needs to return true or false for whether or not the score is above 100. So if the score is above 100, return true. If it's below or equal to 100, return false. string, it's kind of hard to see this way. So what we can do is string, it's kind of hard to code over to a team member to work on that practice to follow. Now down here with our add function, we have A and B. Now what is A and B? If you're basically sending this code over to a team member to work on, they might look at A and B and go, is that a number? Is that a boolean? Is that a string? It's kind of hard to see this way. So what we can do is statically type our parameters by basically having the parameter name, then add a colon, and then its type. So we'll go float, because is being sent over. Whereas if we okay, because even though this function takes the second thing is going to be defining the return type, okay? Because even though this function takes in floats, we might want to return a string that says, you know, we had success, or we might want to return a boolean, true or false. So also defining the return type can be valuable. Now to do that, I'm going to go to the end of the function declaration here, just before the colon. I'm going to go space. I'm then going to add in a dash and then a greater than sign, okay? So it looks like a little arrow. And then I'm going to write down float. So essentially what I'm doing here is I am saying that the add function is going to return a floating point number. A decimal number with this little arrow pointer here. Now again, this is optional, but it is best practice to follow as later. The type hard-coded, okay? Again, this is not something you have to do, okay? Writing down score equals 5 works just fine, but if you have a bunch of variables, it's generally nice to know exactly what that variable type is. So statically typed, we have A and B as the inputs, being essentially is the add function, adding together 5 and 8. And what this is doing is then basically like temporary variable add, which takes in two parameters, A and B. Now, a good way of thinking of parameters is basically like temporary variables, okay? We are essentially declaring a variable for this function to use, okay? And once this function has finished running, those variables essentially just get deleted. Now, inside of the ready function, we are calling the add function, adding together 5 and 8. And what this is doing is then printing out the results. But what if, for example, we wanted to have that result? What if we wanted to be able to then use it? Well, that is where returning comes into play. Returning essentially is the final little topping of a function, okay? A good way of thinking of functions is like a factory. You have inputs, you then have the process, and then you have the output, okay? For example, inside of the add factory here, we have A and B as the inputs being shipped in. Then we have the calculation here being actually, utilizing those parameters and creating something new. And then what we can do is return, which is then outputting the result. So what I'm going to do is replace the print line of code here instead with the word return, a space, and then sum. So what we are doing here is returning the sum, but What does that mean? Well, what we can then do up inside of the ready function is print out this function here. Now, this looks a bit strange. I'm printing out a function, but since we are returning a value here, basically you can look at this as being the number that gets returned. So if I press play, we should have the number 13 in the output, okay? A better way of looking at this might be like this, all right? So I'm going to create a variable here called results, and this is going to be equal to the add function, which is going to send over the number, let's just say 33 and 91. Then what we can do is print out that result. So we can go like so. Now, basically what we are doing here is the add function is going to add 33 and 91 together. It is then going to return that number. So returning it basically means that it is then going to, in its essence, be equal to that number. And we are then assigning it to the result variable and then printing it out. So if I press play, we should see that 124 gets printed. So that is basically the basics of returning values. Okay, so I hope you had a go at that challenge. Let's now hop over into Godot and have a look at how it can be done. So what we're going to do is we are going to go ahead and create a new function. So let's go to a new line down here. And this function is going to be called has1, okay? So basically has won the game. We are then going to have a score that gets sent over, and this is going to be a score of type integer. Now, since this function is going to return true or false, let's go ahead and define that here. So I'm going to go dash greater than, and then write down bool, as this is the type of variable or type of data that we are going to return. Then inside the function, we are simply going to check to see if score is greater than or equal to 100. Now, what is this greater than or equal to sign? Basically, what this is checking to see if the score on the left is greater than or equals to 100. Now, if that's the case, we are going to return true, else we are going to return false, okay? And again, with greater than equals, we also have less than or equals as well. Okay, so that's just a little extra bit for the if statement there. So if our score is greater than or equals to 100, we return true. Otherwise, we return false. So now inside of the ready function, I'm going to create a variable called game over. And this is going to be equal to the has1 function, and we'll send over a score of, let's just say, 120. And then we will print out that game over result. Now let's press play. And we should see true. Okay, we have won the game. But if I set the score to, for example, be 5 and play that, you'll see that it says false, because of course we don't have enough score to end the game. So there are many ways that functions can be used inside of Godot, and you'll definitely be using these in the future for all sorts of purposes. You'll be adding in all sorts of inputs and having all sorts of outputs for your functions as well. So thanks for watching, and I'll see you all in the next lesson. Hey everyone, in this lesson we are going to be looking at vectors. So vectors basically allow us to represent a position or direction in code. Now I'm going to hop over into Godot and start teaching you about what vectors are and how we have actually already used them. So here I am back inside of Godot, and what I'm going to do is actually not go into our script just yet, but instead go over into 2D mode at the top of our screen, okay? Remember, we're in our intro to scripting scene here, and I'm going to add in a new node. So I'm going to go down to sprites, and I'm going to drag in my player PNG to create a new sprite 2D node. Now, we got our player here, and we can of course move them around. And in the inspector, if we open up the transform section, we can see our position, which has an X and a Y, and that will of course change depending on where we move our player to. Now, this position is actually what is known as a vector. If I hover over position, you'll see this pops up, and this basically tells us how we can access this position property inside of code. And at the top, you can see it says vector2. A vector2 is essentially a vector with two different axes, an X and a Y. Whereas in 3D, if I hop over to one of my 3D scenes here, select an object, go to transform, hover over its position, you can see it's called a vector3, okay, because it has X, Y, and Z. Now again, a vector can be used for many things. In terms of position, it is being used as coordinates. So the X is the number that our player is positioned horizontally, and the Y is the amount of pixels that our player is positioned vertically. So this vector can then be utilized to position our player, and what we can do inside of our code is change this position vector to whatever we want, and even over time, so we can simulate the player moving in real time. So what I'm going to do is put my player about here, so that if I press play, we can see they are at the top left corner of our screen. Then what I'm going to do is go into the inspector of that player node, and down at the bottom where we have the script property, I'm going to create a brand new script. So we'll create a new script here. I'm going to save this to my scripts folder that I created, and I'm going to call this one mover.gd, okay, mover.gd. So click open, click create, and there we go. What I'm going to do is go into the inspector at the top, so that if I press play, we can see they are at the top left corner player node, and down script here, I'm going to save this to my scripts folder that I created, and I'm going to call this one mover.gd, okay, mover.gd. So click open, click create, and there we go, the script is now created. Now inside of this script, what we are going to do is essentially just move our player around. So let's start with the ready function, so func ready. And inside of here, we are going to look at how we can actually access our position. So if I hover over that player's position property again, you can see at the top of this little box, it says property, and then in white text, position, okay? So this is something we can actually type down inside of our script. So if I write down position, you can see it pops up here. Now, this little icon to the left basically denotes what this thing is. So P stands for property, aka variable. The F stands for function. So if I go position, and if I print this out, what we should see is our player's position being printed to the output here, okay? 99 on the X and 100 on the Y. Now, what if we actually then modify this variable? So what we can do is go position, and then for example, if we want to modify the X value, we can go .x equals, and then we can go, for example, 400. So what we are doing here is we are getting the position vector. We are then accessing the X value. So if you remember here in position, we have an X and a Y. .x means we're accessing the X value, and we are setting it to 400. So now if I press play, you'll see that the player is now at 400 pixels to the right. Okay, I can bump this up to maybe 900, and you'll see that they are even further over, okay, which is great. Now we can do the same thing with Y. We can go position dot Y equals, and then we can go maybe 500, okay, and then press play, and there we go, the player has moved around. But this is how we can modify the individual axes right here. But instead what we could do is also go ahead and modify the vector as a whole, okay? So what I'm going to do is go position and then equals vector2, okay, with a capital V, and then inside of parentheses, we want to give it an X and a Y. So let's go maybe 500, comma, 200. So what we are doing here is setting the position vector variable as a whole. So vector2, 500, 200, okay? If I press play, you can see that the exact same thing happens. We move our player over. So there's just two ways of modifying the player's position. You can modify the individual axes themselves or the vector as a whole. Now what we're going to do is I'm going to make it so that every single frame our player is actually going to be moving, okay? So how do we do that? Well, I am going to go ahead and create the process function with that delta parameter. Now remember, the process function does not get called once at the start of the game, but rather every single frame, okay? So inside of here, what we can do is basically change our player's position by a tiny little amount every single frame to move them. So here I'm going to go position.x plus equals 1. Okay, so what this means is that every single frame we are moving to the right at 1 pixel. So if I save that, then press play, you'll see that the player is now moving. Okay, every single frame they're moving 1 pixel to the right. Okay, their position is being updated. We can also then, for example, plug this in as a variable. So I might have a variable here called speed, and this could be of type float equals, let's just say 10. And then instead of plus equaling 1, we can then go plus equals speed. So now we are increasing by a variable here. I can press play, and they're moving across the screen. But there is one issue here, and that is we don't want our speed to be in terms of pixels per frame, but rather pixels per second, because remember, people are going to have different frame rates on their computer, okay? If we are changing our player's position based on frame, then what that means is if one player is playing on maybe 20 FPS, they're going to move slower than someone who's playing a game at 100 frames per second. And that is an issue. We don't want different players to have different player speeds based on their computer's frame rate. We want the speed to be consistent, no matter if you're at 1 FPS, 10 FPS, 60, 100, 1000. It should all be the same speed. So what we are going to do here is utilize this delta parameter. Now, I mentioned before, but basically delta is the time between frames. So if you have a faster frame rate, this number is going to be smaller. If you have a slower frame rate, that means frames are going to be happening a lot less frequently, thus delta is going to be a larger number. So what we can then do is multiply speed by delta. And if I save this and then press play, what you'll notice is we are no longer moving at 10 pixels per frame, but rather 10 pixels per second. And in that case, we probably then need to bump up our speed. So I'm going to change the speed here to be 100, okay? And now we are moving 100 pixels per second, okay? So if our frame rate was very, very slow, we would still be moving at the exact same speed as you see on screen here. We can also then move not based on axes, but rather based on modifying the vector. So I'm going to create a variable here and call this one direction. And I'm going to make this equal to vector2, and we'll just go 1 on the x and 1 on the y, okay? Then what I'm going to do is go position plus equals direction times delta times speed. So what we are using a vector here for is a direction, okay? We are defining basically an arrow. So think of a point on a graph at 0, 0, and then another point at 1, 1, okay? This would be to the right and down. So the arrow is sort of pointing down and then 45 degrees to the right, okay? To the bottom right corner. And what we are doing is we are increasing our position by that direction, multiplied by delta to convert that to a per second time frame, and then by speed to basically give it the 100 pixels per second. Now, if I press play, you can see this is then moving. We can then change our direction. Maybe we want to make it move directly down. In that case, we would go 0 on the X and then 1 on the Y. Press play. We are now moving directly down. So that is just a quick look at vectors inside of Godot. Hey everyone. everyone. Now, we code, and at the top you can see it says vector 2. A vector 2 is essentially a vector with two different axes, an x and a y. Whereas in 3D, if I hop over to one of my 3D scenes here, select an object, go to transform, hover over its position, you can see it's called a vector 3. It is change this position vector to whatever we want, and even over time, so we can simulate the player moving in real time. So what I'm going to do is put my player about here so that if I press play, we can see they are at the top left corner of our screen. Then what I'm going to do is go into the inspector of that player node and down create, and there we go, the script ready. And inside of here, we are going to look at how we can actually access our position. So if I hover over that player's position property again, you can see at the top of this little box, it says property and then in white text, position. Okay, so this is something we can actually type down inside of our script. So if I write down position, you can see it pops up here. Now, this little icon to the left basically denotes what this thing is. So P stands for property, aka variable. The F stands for function. So if I go position and if I print this out, what we should see is our player's position being printed to the output here, okay? 99 on the X and the Y. So what we can do is go position, and then for example, if we want to modify the X value, we can go .x equals, and then we can go, for example, .400. So what we are doing here is we are getting the position vector. We are then accessing the X value. So if you remember here in position, we have an X and a Y. .x means we are accessing the X value, and we are setting it to now at 400 further, or Y equals. But instead what we could do is also go ahead and modify the vector as a whole. Okay, so what I'm going to do is go position and then equals vector 2, okay, with a capital V, and then inside of parentheses we want to give it an X and a Y. So let's go maybe 500, 200. So what we are doing here is setting the position vector variable as a whole. So vector 2, 500, 200, okay? If I press play, you can see that the exact same thing happens. We move our player over. So there's just two ways of modifying the player's position. You can modify the individual axes themselves or the vector as a whole. Now what we're going to do is I'm going to make it so that every single frame our player is actually going to be moving, okay? So how do we do that? Well, I am going to go ahead and create the process function with that delta parameter. Now remember, the process function does not get called once at the start of the game, but rather every single frame, okay? So inside of here, what we can do is basically change our player's position by a tiny little amount every single frame to move them. So here I'm going to go position .x plus equals 1. Okay, so what this means is that every single frame we are moving to the right at 1 pixel. So if I save that, then press play, you'll see that the player is now moving, okay? Every single frame, they're moving 1 pixel to the right, okay? Their position is being updated. We can also then, for example, plug this in as a variable. So I might have a variable here called speed, and this could be of type float equals, let's just say 10. And then instead of plus equaling 1, we can then go plus equals speed. So now we are increasing by a variable here. Can press play, and they're moving across the screen. But there is one issue here, and that is we don't want our speed to be in terms of pixels per frame, but rather pixels per second, because remember, people are going to have different frame rates on their computer, okay? If we are changing our player's position based on 20 FPS, right, I'll utilize this basic frame rate, this number is going to be smaller. If you have a slower frame rate, that means frames are going to be happening a lot less frequently, thus delta is going to be a larger number. So what we can then do is multiply speed by delta. And if I save this and then press play, what you'll notice is we are no longer moving at 10 pixels per frame, but rather 10 pixels per second. And in that case, we probably then need to bump up our speed. So I'm going to change the speed here to be 100. Okay. And now we are moving 100 pixels per second. Okay. So if our frame rate was very, very slow, we would still be moving at the exact same speed as you see on screen here. We can also then move not based on axes, but rather based on modifying the vector. So I'm going to create a variable here and call this one direction. And I'm going to make this equal to vector 2, and we'll just go 1 on the x and 1 on the y, okay? Then what I'm going to do is go position plus equals direction times delta times speed. Then corner to be, and then 1 on the y. Press play. We are now moving directly down. So that is just a quick look at vectors in Hey everyone, in this lesson we are going to have a look at our coin collector game. This is going to be our first complete project inside of the Godot game engine, and it's going to be a fun little game that we are going to create. So essentially the way this game is going to work is we are going to have two things. We're going to have a player and we're going to have a bunch of coins around the level. Essentially the player can move around with the arrow keys, and when they collect a coin they will increase in size. So the coin is going to be destroyed and the player will increase in size, and basically they can then keep on going collecting coins and increasing in size. Now, what are the different parts of our game going to be in a more definitive term? Well, essentially, we are going to first of all create a player that can move around. Then we will create a collectible coin scene. And then when the player collides with a coin, they increase in size and the coin is destroyed. Now let's look at how this is exactly going to work by using a flowchart, okay? So for example, the player is going to then be able to press their arrow keys, which is going to directly affect the player's position. And then we're going to check to see, okay, if the player hit a coin, if they did, then we are going to increase the player's size and destroy the coin. So in the next lesson, we are going to begin on setting this up. So thanks for watching, and I'll see you all there. Welcome back everyone. So let's get started with our coin collector game. So to begin, what we're going to do is create a brand new scene for this game. So I'm going to go ahead and create a brand new 2D scene right here. I'm going to rename the root node to be main, as that's generally what I like to do. It's up to you and what you want to call it. You can keep it node 2D if you wish. We are then going to save the scene, okay, to my scenes folder as coin collector game, okay, something like this. Then we can save that, and here we are. Now, the next thing is going to be adding in our player, okay? We want our player that we can then move around our level with. And to do this, we are going to utilize a node that comes built in with Godot, and this is a node that is great for if you're wanting to have a player that you want for maybe a platformer game or even a top-down 2D game. Okay, so if we go over to the plus at the top left corner and search for character body 2D, you can see with a little description here, it basically says character body 2D is a specialized class for physics bodies that are meant to be user controlled. So I'm going to create that. I'm then going to rename it to be player. But as you can see, there's nothing really on screen here because the character body is not a node that has any visuals. Just yet. So let's go down to our sprites folder and drag in the player node. So now we have created a sprite 2D node, which I'm going to rename to be sprite. And then I'm going to drag it in as a child of player. So now wherever the player goes, so too will the sprite. But we want to make sure that the sprite is centered on the player's origin, because if I press player and press W, you'll see that the player character body 2D node is origined here, whereas the sprite is down here. So I'm going to select sprite, go to transform, and set its position to be 0 on the X and 0 on the Y. Now our player is centered in the character body 2D. Now, you may notice on our character body 2D node, we have this little exclamation warning sign. Basically, this is saying that since we have a character body 2D node, we must have a collision shape 2D node as well. And that is because this character body is meant to interact with other colliders in physics. So what we're going to do is right click on player, go add child node, and we're going to search for collision shape 2D and create that node here. A collision shape 2D is essentially a node which defines a collider, okay? And that again is required for the character body. So with our collision shape 2D, I'm going to go to the inspector, go down to where we have the shape property, and I'm going to set this to be a new rectangle shape 2D. We can then zoom in here and begin modifying. You can hold down Alt when clicking and dragging on these orange circles to basically resize from the center. There we go. And now we have our player. So if I select them and press W to go to the move tool, we can move them over here, and if I press play, there they are on screen. Now, the next thing we need is a script so we can then begin moving our player around. So I'm going to go to our player character body 2D node, go down to the inspector. In the script property, I'm going to create a new script. I'm going to save it to my scripts folder, and I'm going to call this one player.gd, okay, and click create. Now, you'll notice here that at the top of our script, we have this extends character body 2D. This basically means that this script has access to our character body 2D node properties, okay, such as motion mode, up direction, slide on ceiling, and a bunch of other functions and variables that are hidden, okay? And this is what we are going to use to interact and modify, for example, our velocity. So what we're going to do to begin with is create a variable for our move speed, okay? So here I'm going to create a variable, call this one speed. It's going to be of type float, and we'll make it, for example, maybe, let's just say we want to move 100 pixels per second. So we'll go 100 like so. Then we need a function that gets called every single frame so we can begin moving our player around. Now you may be thinking, okay, let's use the process function, but there is one caveat with that, and that is there are sort of two process functions. We have process and physics process. Now, when working with physics, which is what we are using with a character body 2D, it is recommended to use the physics process function. So if we go underscore physics process, you should see it pop up right there. And physics process is very similar to process, okay? If you were to run the code, it would look very similar, but physics process gets called at a fixed time rate per second, which I believe is around 60. That basically means that physics process will be called 60 times per second independent of the frame rate, whereas process gets called based on the frame rate. And this is because physics needs to be consistent, and you can't really have fluctuating calls when it comes to that. So physics process, for all it's worth, is very similar to process, okay? And inside of here, what we are going to do is modify our velocity variable. Now, if we type down velocity like that, you'll see it is a property we can modify, and it is a vector too, meaning it has an x and a y. So if I go, for example, velocity.x equals 10, save it, and then press play, you'll see that nothing happens. And that is because even though we are modifying our velocity, which is a vector that defines our pixels per second movement, nothing is really happening because we are setting the velocity, but we're not doing anything with it. We're not telling our character body 2D node to actually move. So to move, what we're going to do is go to a new line and call the move and slide function. Move and slide basically tells the character body 2D node to utilize the velocity and move around. So now if I press play, you'll see that the character is now moving very slowly at 10 pixels per second to the right. Okay, so we're able to modify velocity, but we want to be able to use our arrow keys. So instead of manually setting the velocity here, we are going to have 4 if statements that's going to check to see if we are pressing the left key, the up key, the down key, the right key, and if so, we are going to set the velocity appropriately. So for this, what I'm going to do is I am going to go if input.is key pressed, and then inside of these brackets, I'm going to go key underscore right. And if that is true, then we are going to go velocity.x plus equals speed, okay? And there we go. And then what we want to do is at the top, make sure every frame we are setting setting our velocity to 0 because we don't want the velocities to stack up on one another. So here we'll go velocity.x equals 0 and velocity.y equals 0. Now I'm going to press play and show it, but then we're going to go over exactly what we are doing here. So I'll press play, and if I press down the right arrow key, you can see we are actually moving around, which is very nice, okay? And when I let go, we stop moving. Now I'll show you what happens if we don't reset our velocity, okay? So if we are just increasing our velocity, this is what happens. And we zip off screen, okay? And that is because we are increasing our x velocity by speed every single physics frame, which, as you can see, just exponentially gets larger and larger. So we need to basically reset our velocity at the start of every frame. Now, what are we doing down here with this if statement, okay? If input.isKey pressed key right, then increase our velocity. Well, this here is basically how we detect a key input. Now, there are many ways of doing this inside of Godot, but this is probably the simplest. Basically, we go input with a capital I, and then we are calling input's isKey pressed function. We are sending over the key that we want to detect, and this function is then going to return true or false. If it is true, then we are going to increase our velocity like so. We can then also do the exact same thing for the left, up, and down arrow keys. So I'm then just going to copy and paste this if statement 3 more times, just so that we don't have to go through and write it all out by hand. So here we'll go key underscore left, and if the left key was pressed, we then want to subtract our x velocity. If the up key was pressed, then we want to modify our y velocity, and we want to decrease that, okay? Because to go up, we have to decrease our y velocity. And then finally, to go down, key dot down, we are then going to increase our y velocity, okay? Just like this. Now, if I go ahead and press play, we can move around with the arrow keys, and we can pretty much now have a little player that can move around on screen. Now, you may be wondering why we are not multiplying this by delta. In a previous lesson, when looking at velocity, or when looking at vectors, we did multiply by delta to convert it from a per frame to per second calculation, but we are not doing that here, mainly because the velocity variable is managed behind the scenes by the character body 2D node. And velocity, all this does is define the amount of pixels we want to move per second, okay? So that calculation is already done for us. Now, in the next lesson, we are going to continue on with this little game. Welcome back. Back everyone. In this lesson, we are going to continue on with our coin collector game, by this time creating the actual coin itself. So what we're going to do is inside of our scene here, I am going to create a new node, and this is going to be of type area 2D. Now, what is an area 2D node? Well, essentially this is a node that can detect when another collider has overlapped it, okay? This is what we use for things that we might want to pick up. Now, it's different from a collision. A collision is where you bump into something. An area is basically something that you want to pass through. So maybe a portal. You might want to detect when the player has entered a portal, so you'll have that as an area 2D node. I'm going to rename this area 2D to be coin. We are then going to go to the sprites folder, drag in the coin PNG, rename that node to be sprite, and then drag it in as a child of the coin. Then in the inspector, I'm going to go down to transform and set its position to be 0, 0. So now our coin, if we press W, is got that child sprite that follows along in the center. Now with an area 2D, we also need to add a collider. So I'm going to add in a collision shape 2D. And in the inspector, we are not going to make the shape a rectangle, but rather a circle because the coin is round. So we can select that and then change the size just like that. There we go. Next, what we need to do is select the coin, go down to the inspector and create a script for it. This script is going to be in my scripts folder, and I'm going to call this one coin.gd. Okay. And there we are. Now, the way that collision detection works, because right now if you press play, you can see we can go to the coin, move through it, but nothing happens. And the reason why is because even though this coin is actually detecting the player overlapping it, it's not doing anything with that information because we haven't told our script that it needs to know that just yet. So what we're going to look at, and not actually go into too much detail, but we are going to explore it a little bit, is the idea of signals inside of Godot. Signals are essentially like events. When something happens, a signal gets emitted, and that signal can be connected to functions inside of your script. So if I select my coin here, go to the inspector, you'll see at the top we have another little tab here called node. If I select the node tab and then select my coin, you'll see that we have all of these different signals, okay? And a signal, like I mentioned, is basically an event that gets emitted when something happens. For example, down here we have the mouse entered signal. This signal gets emitted whenever our mouse cursor enters this object's collider. We have, for example, the body entered signal when another body or another physics body, such as our player, enters the collider. And that is the signal we want to connect to. So I'm going to double click on this signal. I'm then going to select my coin, which contains that coin script, and then I'm going to click connect. Then finally, a new function is going to automatically be created called onBodyEntered with a body parameter. Now, what essentially this means is that whenever another physics body enters the coin's collider, this function is going to be called, okay? And that's pretty cool. Now, you can tell it is a signal function by the fact that we have this little green icon on the left-hand side here. So inside of this function, what we're going to do is first of all increase the scale of the player, and then we're going to destroy the coin. Let's actually look at destroying the coin first. So to destroy a node inside of Godot, basically you want to write the function qFree. Now qFree is a function that basically destroys the node that this script is attached to. So if I save that and then press play, you'll see, whoops, not that play, the other play, you'll see if I move over the coin, it is going to be destroyed, okay, because it detected that another physics body has entered its collider, and thus this function was called, and we have destroyed the coin. But we also want to increase the player's size. So to do that, we first of all want to access the player by going body, because the parameter that gets sent over is actually going to be the player's node, okay? And since it's sending over the player's node, we can access its scale property. So we can go body.scale.x, and we'll just go plus equals 0.2. And let's do the same thing for the y-axis as well. Body.scale.y plus equals 0.2. So we are essentially increasing the player's scale by 0.2 every time they pick up a coin. So now if I press play, you'll see that when I pick up the coin, the player gets bigger, okay, which is great. Now what we can do is save this coin as a scene. Now to save the coin as a scene, we can right click on it and then go down to where it says save branch as scene. And then what we're going to do is go to our scenes folder and save it as collectible coin, okay, just something like that. And there we go. So now we can duplicate this coin, move it around. To basically whatever position we wish and have as many of them as we want. So if I press play, you'll see that our player can then go around and collect all these coins like that. Finally, let's set up a camera that can follow our player around. So on our player node as a child, I'm going to right click on player, go add child node and search for camera 2D. Now, if I zoom out, you can see this purple rectangle is basically what the camera is going to see. So if I save and press play, there we go, our player is in the center, and the camera actually moves with them because since the camera is a child of player, wherever player goes, so too will the camera. We can also then choose to zoom in our camera by changing the zoom vector here. Maybe we'll make that 1.5, save it, press play, and there we go. The camera is zoomed in a little bit here. Hey everyone! We just finished creating our coin collector game inside of Godot. Now, this was a fun little game where basically the player can move around and collect coins. So we set this up with a number of different scripts. We started, of course, with a player script that allowed us to move the player around. Now, this script was attached to a character body 2D node, which is essentially what we use for characters inside of Godot if you want them to interact with physics objects, which in our case, to detect collisions, we need objects to basically be using the physics system, okay? And then we created a collectible coin, which was an area 2D node. Essentially, an area 2D is like a collider that can detect collisions, but things can pass through it as well, so it's not a solid wall. Again, think of like a portal, for example. And then when the player collided with the coin, we increased the player's size and destroyed the coin. So we have this nice little game where basically the more coins the player collects, the bigger they get. So from here, you can create pretty much whatever game you wish. Of course, though, it's going to take time and effort and practice, but if you keep on practicing at game development and Godot, eventually you'll be able to create pretty much whatever you wish. Hey everyone, in this lesson we are going to be looking at how we can export our game from Godot. Now exporting essentially means packaging up all of our assets, all of our scripts and everything we have created, all of our scenes into an executable file that you can then launch. Okay, this is very handy if you want other people to test out your game or upload it to the internet. So what we're going to do first of all is go up to Editor, then down to Manage Export Templates, okay? Because with Godot, in order to build our game to Windows, Mac, Linux, or any other platform, we need to download the export template. And by default, it doesn't come with Godot simply because these files can be quite large in size and you don't really need them straight away or all of them. So I'm going to click on the Download and Install button right here, and that is going to begin the process. Now, template and all is go up to Editor, then down to Manage Export Templates. Okay, because with Godot, in order to build our game to Windows, Mac, Linux, or any other platform, we need to download the export template. And by default, it doesn't come with Godot simply because these files can be quite large in size and you don't really need them straight away or all of them. So I'm going to click on the Download and Install button right here, and that is going to begin the process. Now, you will notice that it is around a gigabyte in size, and that is, of course, because, like I mentioned, there are a lot of prerequisites and other boilerplate things that you need if you're building to Windows, if you're building to Mac, and this is just downloading all of that for us right now. And there we go. It is now completed the installation. So we can close out of this window. Next, we're going to go up to Project and then go down to Export. Now, inside of this window here, we need to create a brand new export preset. You would create a new preset, one for Windows, one for Mac, one for Linux, etc. So I'm going to click on Add right here and then choose my platform. Now, since I'm on a Windows desktop, that is what I'm going to build to. So I'm going to select Windows Desktop. Now, all the options here on the right-hand side, you don't really need to mess with any of these things. Of course, you can research more if you want icons and more specific stuff like that. But I'm simply going to go over down here where we have Export Project, select that, and then I'm going to choose a location for this executable. So I've got a folder here called Godot Games, and what I'm simply going to do is I'm just going to create a new folder here for my game. I'm going to call this My First Godot Game, and then we can name the executable. So I'm going to call this one My First Godot Game as well. Now it's pretty quick because we have a fairly small game to work with, but if I go ahead and get that folder up right now, you can see right here, we have My First Godot Game, that folder we created, and inside of here, we have our executable. Now, I'm simply going to double click on the executable, and that is going to launch our game. Now, of course, we set the default scene previously to be this one, so that's why we don't have the coin collector minigame up, but as you can see, we have our game up and running in its own little window. Now, if you were to want to share this game with people, you would simply have to zip up this main folder right here, which contains the 3 files, and send that over, okay? It is as simple as that. Congratulations on completing the course. We just finished having an introductory look at the Godot game engine, okay? And we covered a range of different topics. We first of all looked at installing Godot, creating a new project, and then exploring the Godot editor, okay? At first glance, there seemed to be a lot of different things, buttons, panels, bits of text, input fields, but as we continued on, we started to learn more and more about what each of these things do and how they serve us in creating our games. We then jumped into learning the fundamentals of Godot as well as 2D development, such as nodes, scenes, tools, parenting, and cameras. We then looked at learning 3D, which involved 3D environments, models, materials, and lighting. And then the second half of the course was spent learning scripting, okay? Right from the very beginning, we learned about variables, conditions, operators, functions, vectors. We learned about all the basics when it comes to logic in programming inside of Godot using the GDScript language. And then finally, we created our little coin collector minigame, which put all of that knowledge to use, as well as learning a few little things more. Zenva is an online learning academy with over 1 million students. We feature a wide range of courses for people who are just starting out or for those who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to follow along with videos, read the included lesson summaries, or follow along with the instructor with the included course files. So thank you very much for following along with the course, and I wish you the best of luck with your future Godot games.